Welcome to episode 08 of CipherVibe's end-to-end cloud security architecture course. Zero Trust architecture moves protection from a static network location to the identity, device, resource, and context of each request. It assumes no implicit trust merely because an identity or workload is inside a network. We will connect its purpose, design boundaries, implementation path, failure modes, and evidence of effectiveness. Every cloud security layer relies on the ones around it. It unifies authentication, authorization, device posture, microsegmentation, application gateways, and telemetry. Zero Trust does not replace these controls, it gives them a common request-level decision model. Treat the architecture as a chain. A trusted identity requests an action, a policy makes a decision, a workload or data service enforces it, and telemetry records enough context to investigate later. The first building block is protect resources, not locations. Begin with the resource and its sensitivity, then define which identities, devices, services, and contexts may use it. Do not treat a corporate network, cloud VPC, or VPN as proof of authorization. Require a decision before access is established and reevaluate when risk changes. The second building block is use ZTNA for application access. Zero Trust network access brokers an authenticated, authorized path to a specific application or service. It can reduce lateral movement compared with broad remote network access, but it still needs accurate identity, application inventory, policy ownership, and visibility into denied decisions. The third building block is apply SASE consistently. Secure Access Service Edge platforms combine functions such as secure web access, CSE-style controls, firewalling, and ZTNA. Their value comes from consistent policy and evidence across distributed users and branches, not from simply moving an existing network rule set into a new service. The fourth building block is verify continuously. Use relevant contexts such as device health, location risk, session behavior, data sensitivity, and workload identity. Design graceful step-up and remediation paths so controls are usable, privacy-aware, and resilient when a context signal is unavailable or falsely negative. Use this reference pattern. Begin with an explicit policy that describes the permitted outcome. Enforce that policy at the closest reliable control point. Route decision and activity evidence to protected storage. Then give an accountable team a tested path to review exceptions, correct drift, and respond to violations. A practical Zero Trust pattern catalogs protected resources, evaluates each request through a policy decision point, enforces at an application or service boundary, and streams decisions for review and rapid revocation. Implement this layer in a sequence that preserves evidence and limits blast radius. First, choose one high-value resource and map its request path. Second, define identity, device, and risk requirements. Third, deploy an identity-aware enforcement point in monitor mode. Fourth, replace broad remote access with resource-scoped access where appropriate. Fifth, measure failures, user impact, and policy decisions before expanding. Prefer pilots with a named owner and rollback plan over an unmeasured organization-wide switch. The best rollout is one where a normal workflow succeeds, an unsafe path fails closed, and the team can explain the decision from logs rather than intuition. Security architecture fails most often through assumptions, not dramatic movie-style attacks. First, buying a Zero Trust product without a resource and policy model. Second, assuming device posture is always accurate or available. Third, creating a brittle access experience with no recovery path. Fourth, ignoring workload and service identities while focusing only on employees. A configuration screen is not assurance. Collect evidence that the intended control applies to the correct scope and that violations become visible. First, test access from compliant and non-compliant device states. Second, verify denied sessions cannot reach adjacent resources. Third, monitor policy decision latency, bypasses, and emergency access. Fourth, review whether resource inventory and policy ownership remain current. Test both normal activity and a safe negative case in an authorized environment. Record the expected decision, the evidence location, the owner who reviews exceptions, and the rollback method. Repeat after platform changes, new integrations, or major shifts in business use. For a practical exercise, define a Zero Trust access flow for a production administration portal used by remote engineers. Use synthetic information or an environment you own or are explicitly authorized to administer. Deliver a one-page diagram, a concise control statement, a list of expected audit events, and one test for an allowed path plus one test for a denied path. This artifact is more valuable than a screenshot because it explains the reasoning behind the configuration. Before scaling this layer, ask 5 review questions. Which assets, identities, or environments are in scope? Who owns the desired state and exception decisions? Which enforcement point can reliably apply the rule? Which records prove the decision and retain enough context for an investigation? And how can the organization revoke access, contain impact, or roll back safely when a control fails? Good architecture makes these answers explicit and testable. The key lesson is that Zero Trust architecture becomes dependable only when design, policy, enforcement, evidence, and ownership move together. Document the decisions you make, remove permissions and exposure that do not support a real requirement, and rehearse the paths that matter before an incident forces the lesson. Continue through the next episode to connect this control layer to the rest of the CipherVibe cloud security architecture.